Hey, welcome back to Algebra 1. We are talking about 10-7 similar triangles. Similar triangles are triangles that have the same shape, but not necessarily the same size. So, if two triangles are similar, then the measures of their corresponding angles are equal. Okay, important, highlight this, write this big and bold. The angles are equal, and their measures of the corresponding sides are proportional. Angles are equal, sides are proportional. So it's same shape, not necessarily same size. So if you look at this example right here, we've got two triangles. This is a special type of triangle. It's a 30, 60, 90. And you'll see more of this when you go into geometry. Now here, notice the angles are the same. We've got a right angle, we've got a 30 degrees, and a 60 degrees. And the sides are proportional. So this side times 2 gives me 6. 3 times 2 gives me 6. 6 times 2 gives me 12. So the sides are proportional. And we can find that ratio, or the scale factor, by dividing one side by the other. 6 divided by 3 gives me that scale factor, 2. And then I can multiply the other sides by 2 to find the corresponding sides. Okay, if I want to determine are they similar, then either the sides have to be proportional or they have to have the same angles. So here I can check for this angle up here to see, well, is this one 66? In order to do that, I can add these up. In a triangle, we have 180 degrees, so add these up, subtract that from 180, and then you get x is 66. So this angle is indeed 66. However, one angle being the same measure is not enough. So we need to figure out what these down here are. Now this sign means that these two angles are congruent. That means this is the same measure as this one. So I can set that up as all three of these added together. This one and the two I don't know, which are equal. So x plus 66 is 180. So I'd subtract the 66 from 180. And then my result gives me how much these two are together. So that's 2x is 114. And then divide that by 2, and I get x is 57. So one of those is 57, and since they're congruent, that means the other one is also 57. Okay, now I can look at these and compare them. I have 66 and 66, and the other measures are 57. So, since the corresponding angles have equal measures, then triangle XYZ is similar to STQ. Now notice here, this first triangle is listed in alphabetical order. The second one is not. Okay, X corresponds to S. So x is in the same place as S. Y corresponds to T. That's the angle with 66 degrees. So Y has to be in the same position as T. Okay, if you were to rewrite this XYZ and then over here TSQ, that would not be a correct similarity statement. Alright, determine if the two triangles are similar. Remember, we can either check angles or we can check proportions. In this case, we're given the lengths of the sides, so we'll check proportions. I'm going to take this long side, VX, and compare that to the corresponding side in the small triangle, WX. So that gives me 12 over 4, and then I can simplify that or divide it, and I get a ratio of 3. Then ZX to YX, that's 15 to 5. That also gives me a ratio of 3. And then VZ to WY, 9 over 3, is also 3. So all of these have the same factor between them. So since corresponding sides are proportional, I can say that VXZ is similar to WXY. Okay, if I want to find a missing measure in similar triangles, I know that they are similar. I can check the angles here, 60, 82, 38, 60, 82, 38. Okay, they are similar. Then I have sides I know, and then what I'm missing here. I'm looking for A and C. So those are the ones we want to find. There are several ways you can do this. You can find the scale factor between the two, and then multiply the other sides by that scale factor. Or you can just set up a proportion, as in what we're looking for, A to 7 is equal to 12.5 over 5. Now I recommend putting the variable on top. That means the triangle with the missing measure is going to be listed on top. In this case, both of these measures come from this triangle. It's important that those stay together. Okay, so down here, 5 is shorter than 12.5, so I'll call this the smaller triangle. Both the measures from the smaller triangle are on the bottom. That's very important when you're setting up a proportion, that you keep those shapes together. Now we can cross multiply to solve that. 5 times A is 5A. 7 times 12 is 87.5. Divide by 5 on each side, and we get A is 17.5. Follow the same procedure to find C. We'll do C over 8, since that's the corresponding side, and then 12.5 to 5. And cross multiply to solve, divide by 5, and we get C is 20. And that's all for today, folks. Like and subscribe.